Hello dear students, good morning. Welcome back to the chemistry class. So in the last class just we have started the topic solution. So just once you recall the concepts and then we'll move for some numericals. So in this topic we have discussed about the some basic terminologies, basic terminologies, basic terms. That is, what is meant by the term solution? Can you define the solution? Yes, solution is nothing but what? Solution is nothing but it is a homogeneous mixture of homogeneous, that is uniform mixture of homogeneous mixture of solute and solvent. Solute and solvent. Solution is nothing but a homogeneous mixture of two or more components, two or more substances are known as solutions, right? So solution is equals to solute plus solvent. We can write solution is nothing but solute plus solvent. The substances which makes the solutions are generally we can call components, and here it is two components, one is solute and other one is solvent. So what is meant by the term solute? Solute is nothing but what? So solute is nothing but the component, a component of a solution which is present in lesser quantity, lesser proportion is known as solute, whereas the component which is present in larger quantity, larger proportion, and the component which is present in smaller proportion, it is a small proportion and it is larger proportion, larger amount is known as solute, and the component which is present in largest amount, largest proportion, largest quantity is known as solvent, whereas the component which is present in the smaller amount is known as solute, right? The basic terminologies we have defined the term solution, defined the term solute and solvent. Now, depending upon the different properties, we have classified the solutions into following types of solutions. The first one is depending upon the number of components present in the solutions, it is classified into depending upon the number of components, depending upon the number of components, it is classified into binary solution, that means the solutions which containing only two components, the solutions which containing only two components. If the solution containing only two components, then it is called as binary solution. If the solution containing three components, ternary solutions. If it containing four components, quaternary solutions. Quaternary solutions if the components is equals to 3, if it is equals to 4. If the solutions which containing two components, it is called as binary solution. If the solution containing three components, A plus B plus C, any three components which is mixed to make the solution, that is called a ternary solution. If we are preparing the solutions with four components, it is called quaternary solutions. Depending upon the number of components, it is classified into these types, right? Okay. Now, depending upon the solvent used, depending upon the solvent used, it is classified into two types. One is aqueous solution. Second one is non-aqueous solution. Already you have used these terms, aqueous solutions and non-aqueous solutions. What is the meaning of this aqueous solution? Aqueous solutions is nothing but the solvent must be water. Solvent must be water. Compulsory. The solvent should be water. Then only we are using the term aqueous. Wherever we are using the term aqueous, that means the solvent is water. Other than non-aqueous solutions, if the solvent is other than water, the solvent is other than water, like organic solvents, CCl4, carbon tetrachloride, carbon disulfide, benzene, kerosene, etc., then the solutions is said to be non-aqueous solution. One is aqueous solution and the second one is non-aqueous solutions. Now, one more type, depending upon the physical state of solvent medium, based upon the physical state of solvent, based upon the physical state of solvent, it is classified into three types. One is solid solution, second one liquid solution, solid solution, liquid solution, and gaseous solution. Solid solution, liquid solution, gaseous solutions. Now let us explain briefly about these three here. Solid solutions, liquid solutions, gaseous solution. That means in solid solution the solvent must be in solid state. So if the solvent is in liquid state, those are called as liquid solution. If the solvent is in gaseous medium, then it is called as gaseous solution. Please note this. So in this topic, the first term is definition, basic terms, solution. Solution is defined as it is a homogeneous mixture of two or more components. The proportions may be varies within certain limits. So the component which is present in the smaller quantity is known as solute, and the component which is present in the largest quantity is known as solvent. So depending upon the number of components, it is classified into binary, ternary, quaternary. Depending upon the solvent used, if the water is solvent, it is termed as aqueous. If other than water, it is called as non-aqueous solution. And based upon the physical state, it is of three types. So one is solid solution, second one is a liquid solution, third one is gaseous solutions. So here, if the solute and solvent, solute may be solid, liquid or gas. It may be solid or it may be liquid or it may be a gas. If the solid is dissolved in solid, the solvent is solid. Then these are known as different examples you can write. So these are solid solutions. Examples we have discussed, and even in NCRT they have mentioned a simple table, so you can note it. First one, solute. It may be solid or solid dissolved in solid, liquid dissolved in solid, or gas dissolved in solid. If the solvent is solid, the solutions are known as solid solutions. Solid, liquid, gas, it may be dissolved in liquid, then it is known as liquid solutions. So liquid solutions means which means that solvent must be in liquid phase, then only it is called a liquid solutions. Solid may be dissolved in liquid, liquid dissolved in liquid, or gas is dissolved in liquid. So these types are known as liquid solutions. Solid, liquid, gas, it may be dissolved in gas. If the physical state of solvent is gas, then it is known as gaseous solution. Gaseous solutions. Can you give some examples? Yes. You can fill the examples. So give some particular examples where the solute is solid. Solid is dissolved in solid. One example for solid dissolved in solid. Simple example is metal alloys. 22 karat gold, 24 karat golds we are not used for jewelries. So 22 karat gold, because remaining 2 karat is copper. 22 karat plus 2 karat. 22 karat gold, 2 karat copper is mixed uniformly. A homogeneous mixture of gold and copper. 22 karat gold. So that is metal alloys. Metal alloys are the example of solid solutions. Some examples of liquid is dissolved in solid. Amalgams. So mercury is a liquid with sodium. Mercury, sodium amalgam, or simply we can call metal amalgam. Metal amalgams. Gas is dissolved in solid. Is any examples where gas is dissolved in solid? Yes, hydrogen gas in nickel, palladium or platinum. Nickel, palladium or platinum. Adsorption of gases on the metal surface is an example of this kind. Adsorption of gas on the metal surface is an example of solid solutions. Now, this kind of example, particular liquid solutions are very common. So you can give number of examples for this kind. Solid in liquid, solid in liquid, salt plus water, sugar plus water, etc., etc. Liquid in liquid, milk plus water, ethanol plus methanol, ethanol plus water, etc. Different examples we can give. Gas in liquid, carbon dioxide plus water, carbon dioxide, nitrogen gas, oxygen gas, dissolved oxygen in water, gas in liquid. Different number of examples we can use for this kinds. Gaseous solution, solid dissolved in gas. Solid dissolved in gas, in gaseous medium. So simple dust particles, smoke, carbon smoke or dust particles which dissolved in the gas. Liquid in gas, water vapors, water droplet, humidity, water droplets are distributed in air. Gas in gas, a mixture of air. Simple one example I have mentioned in the previous sessions also we have explained regarding this. So that video which is prepared in the last year, right? Okay, next. So this is regarding the types of solutions. Now we are moving to the most important concept from this is regarding concentration. Concentration of solutions. So what is meant by the term concentration? In class 11, in the last year, class 11, first topic, some basic concepts of chemistry, we have discussed this concept, concentration of solution. What is meant by concentration? So we have expressed some molality, mole fractions, even normality also we have discussed, right? So just recall those concepts once again. So here the term concentration which represents that, it means that how much solute is present in a given amount of solvent. Solution, given amount of solution. So suppose if 100 ml of solution is given to you, so how much solute is present in that solvent, in that solution? So we need to express the amount of solute present in the given solution, that is known as the concentration, which represents that, it means that how much solute is present in a given amount of solution. So concentrations may be defined as, this concentration is defined as the amount of solute. It is defined as the amount of solute, which is present, the amount of solute present in a given amount of solution, that is called concentration. Is it clear? Okay, concentration is nothing but the amount of solute present in a given amount of solution. To express this, we have different units. So what are the units? Yes, you have studied, no? Okay, just recall those different units. Number one, first one is by percentage, the basic unit by percentage. By percentage means it may be mass percentage, it may be volume percentage, or it may be mass by volume. M by M, or you can represent W by W, mass percentage, V by V, volume percentage, mass by volume percentage. I will explain in detail. By percentage, second one, ppm. What is meant by this ppm? ppm or ppb. What is meant by these terms? Parts per million or parts per billion. So simple. So first this one is given in your NCERT, ppm, that is parts per million. Parts per million with formula, with one examples, will illustrate now. ppm, whereas the next one is mole fraction. Mole fraction. Fourth one is molarity. Capital M, molarity. Fifth one is molality. Lity, that is small m. Sixth one is normality. Normality. Right? So these are the different units, even normality, formality. So these different units which we are using to express the amount of solute present in a given amount of solution. That is, to express the concentration of solutions, we are using these units. These are the concentration units, right? So in this session, so just we have covered the basic terms, that is the solution, solute and solvent, and types of solution, and about the concentration and its units. So in the next session, we'll explain in detail about the concentration units, right? About the concentration units, definitions, formulas with illustration, that is with some example, we'll explain these terms, right? Okay, thank you.